Well, the Greeks held that the visual arts were the imitation of life, but the computer arts are the imitation of creation itself. Thank you very much.
My function here is really to introduce Gordon Bell and get out of the way and let him set the stage. I observed that in the schedule, there's a bunch of people listed as discussants who really are introducers, and I believe that role of discussant, my understanding of that is really to help moderate comments from the audience, so that people who really have some things they would like to add to this historical record that's being built have a chance to get up and say them. So I don't see myself as getting up afterwards and saying a lot of that. And I say that to you now so that you can in fact be thinking of that, because I'm sure you'll find lots to react to in Gordon's talk. Everyone else does whenever Gordon talks. Anyway, the simplest way, so what the hell, let me just introduce him. The simplest way to introduce Gordon is to say he's one of the world's really leading computer designers, but and that doesn't necessarily seem to recommend him to be the keynote speaker here. There are a couple of other things that might be, it's true actually, that might be said about him that does, it seems to me, make it really quite relevant that he give the keynote speech here. First of all, of course, he's a product of that whole MIT-related environment up in the northeast corner, from which so much of the development of computers has come. He did his work, master's degree at MIT, working with Ken Stevens on speech recognition. He went from there to digital, and was in fact the person who has influenced and been involved in digital's efforts over the years. The 4, the 5, the 8, the 6, the 10, the 11. The 16, nobody remembers the 16 except Gordon and myself and maybe Wes Clark, it turns out. But there was something called the PDP-16, the VAX, all those, not the 12. The 12 is related to the Link and Wes Clark. But all of these things, which in fact play a very enabling role with respect to the topic here today. He did in fact come down to Carnegie, which is when I first met him in the mid-60s. He has this love-hate relationship with digital. And so he went through a hate phase and showed up at Carnegie for about 5 or 6 years before going back to DEC. He never really left, of course, because things like the 11 and the beginnings of the VAX all happened while we were down there. There are a couple of other things that you need to know about Gordon. One of them is he's one of the founders of, key members in founding this computer museum back in the Boston area, which is directed by Gwen Bell. As a matter of fact, although I haven't had a chance to say hello to Gwen yet, she's out here, and she has a big inverse Santa Claus bag. And if anyone has any great artifacts, you're supposed to just dump them in this bag as you leave the room, and she will take them back to the computer museum. So that's another connection. And in fact, Gordon and I wrote a book called Computer Structures back in the early 70s, or to be more precise, because that's the way it always is with Gordon. I helped Gordon to write this book and to kind of clean up the prose and do a few things like that on it. That book really reveals that Gordon is much concerned with trying to lay the frameworks within which things happen. Some of you know this, but our first and preferred title for that book was Computer Botany, not Computer Structures, because in fact we viewed our goal as laying out the whole structure, the collection of those artifacts that were coming along, which one needed to understand and study and classify and so forth. And that same attitude has been with Gordon throughout his career, and I'm sure you'll see it in his talk today. In fact, I could have predicted that Gordon would take the view, which I also have, that you can't really write history about things until you have the space laid out in which that history can occur, sort of no space, no trajectory. And I think Gordon's role for us, at least I hope it will be, is to somehow lay out some of the dimensions of that space so we can then proceed to deal with the history. Gordon?
There you are. Thank you. Right. Actually, when I wrote or accepted this paper, I sort of thought of a half a dozen reasons. The first, of course, was in fact to respond to Alan, who, actually Alan Perlis, because ever since he headed the computer science department at CMU and was my boss, I really have had a hard time ever saying no to Alan. So really that was probably the most single reason that I'm here. And then the second one was that Alan Newell identified was to identify artifacts for the Computer Museum, and as one of the curators of that, to tune up my view view of history that isn't always right. And then the third was, in fact, to do the thing that Alan said which is really to try to posit a taxonomic and an evolutionary framework both in a kind of a Linnaean sense and in a process. How does the technology across all the components drive this? And for that, actually, I always insist on sort of knowing the whole picture, going back to the beginning and see if I can trace it since 1949 or so. And then certainly I feel compelled to write the history into the future. Is no good unless you can get it up to the year 2000. I stop in this one at about 1990. I think it's important to, when you're doing history, to be able to look to the history of the future too. And then it turns out that there were three other reasons, all of which were selfish. One was to think about a book on that, hey, this might be an interesting way of putting such an evolutionary book together, and so I sort of took this kind of as a challenge of maybe, is this a breadboard for an outline? Because I think in terms of breadboards and prototypes and production machines and ultimately obsolescence, I kind of took this as a breadboard for such a book. I don't know whether it is or not. And then it turns out I couldn't help it. I want to apologize that there was some work that I spent actually the last 6 years, or 6 years up until '82, that's now sort of clearly bearing fruit, working on a thing called VAX, and a thing called the VAX strategy, which was the notion of building a hierarchy of machines. And I had to slip that into an appendix because I've never recorded that before, and I'm not at digital any longer, and that's one of the things I didn't do when I was there, and I couldn't help but sort of have to write that little paper to clean up that piece of my life. So there's sort of you'll find this paper as sort of a patchwork quilt, and that's an apology for that piece of the quilt. And then finally, initially I said, well, I didn't really have anything to do with these workstations, but it turns out then I looked at some of these, that a lot of the machines that are being used were used, or the prototypes and then subsequent things was there really a lot of the later machines were doing that, and I had to sort of make some notes about what influenced the thinking there, such as the Park work and also the ARPANET and the importance of those in at least my recollections in the workstations. And then finally, an idea that just came up this morning, which was, or it's been in my head for many years, which is that in fact, as a historian, what we really need is a historian's workstation. So I hope coming out of this conference will be somebody will take on the role of building historian's workstation so that, in fact, histories are much easier to do. It's obviously a very important segment of of artificial intelligence, because artificial intelligence has got a whole subsegment that deals with truth maintenance, and I just keeping track of who did what and when, and I think is an important part of history. In the paper, I certainly talk about a series of concerns about doing history that I stole from the people who had done some history, and especially by the participants. Although a technology historian at the early conferences, don't worry, just put down your recollections. And I think that we've got very high watermarks to come up to in the previous history of computing, which had, at Los Alamos, that conference, which had 30 years of hindsight, and then the history of programming languages, which in fact had 20 to 30 years, with exception of the work on APL, which really started earlier than with 20 years of hindsight. So my concern here is that we maybe don't have enough hindsight in that. If I look at what I was doing 15 to 20 years ago, we were basically trying to get our interactive our interactive time-sharing systems working out those. In fact, 20 years ago, I think one of the first time-sharing systems, the PDP-6, we were just getting it to be time-sharing at that point. So we ought to be a little worried that we've got enough time to look at that. What I thought I'd do first is I'd like to show a film, a quick film that comes from the Computer Museum of some of the first the films. This is sort of, I apologize, and start rolling the film, please. This comes from a copy in the museum that was which the original copies. This is Whirlwind, which a lot of us think of as the first interactive personal computer. This is not the computer. This is not the computer. This is the console room for the computer. The computer is 32 feet long, or 16 bits, whatever you want. This is the machine being used, the bouncing ball program being used on a CRT. And then there was a film that Edward R. Murrow did interviewing Jay Forrester, and this segment shows a trajectory of a rocket that was done in the interview. The film is in the museum and shows this happen. This is the telephone. The editing here is not so good. Now, out of Whirlwind, one of the projects which Doug Ross will talk about came a system called SAGE, which was semi-automatic ground environment for air traffic. This is not the computer. This is the generator room for the computer, which the guy was fascinated with. Again, about a 32-foot computer. It was actually 32 bits. Actually, I think it was a 64-foot computer. Here are the first interactive consoles, obviously a time-sharing system. If you think of these guys as professionals, they're doing work, and so it's not a personal workstation, but it's a shared workstation. They're working to shoot down to identify airplanes that are coming from someplace else. Here are the airplanes that they're dispatching. Some early computer graphics. One was at Project Mac that was done. This is the thing they call the kludge. Doug Ross, I think, will be speaking about this. trackball, and then Sketchpad is not part of the MIT work, but Lincoln Lab. This is in sort of '63. This is a trackball, a thing called the crystal globe, and then some knobs and switches for various kinds of input, some keyboard. And the display there, I have a slide which has more detail later, but it was a deck type 340 that these folks had modified. These were deck modules in the background where they had made the interface to the 7090. And then the neck and sort of the things that wireframe. And this is the beginning of, I think, computer-aided design. This is Ivan Sutherland's Sketchpad program, where he's, Ivan, which we don't see here, has some buttons and then is doing the inking. Here's again, this is not the computer, this is just the console of the computer. It's a not quite, it's a 36-bit computer. It's probably 64 feet long, but and then I'm only showing this because I think I looked in half of the room, and I think hopefully half of you haven't seen this film, but I think this is an important film that people should look at, and certainly everyone who works in computer-aided design, I hope, has read the Sketchpad thesis. And whoops, Ivan saw this and he was apologizing a little bit for some of the graphics. I saw it the other day. And then in '67, Adage made in a film which we have in the this is a film from I'd say it's this is about a third generation film. We have the second generation of all of these in the museum. These films have come, and this is sort of the scaling, rotation, and translation performed in real time on that. I don't have any Evans and Sutherland. I guess we have one Evans and Sutherland footage, but this is in '67. So. A little bit of no shading, but some surfaces and wireframe. And then this is we'll see the RAND tablet here. This is sort of the RAND tablet, I think it was 62. And again, and Bob Balzard, which isn't shown here, but worked on this part, which is the hand recognition. He also worked on showing how to do programming from flowcharts, and I think convinced himself that, like everybody does, that you don't program using flowcharts. But nevertheless, in the mid-'60s, had a program that would recognize flowchart symbols and one could specify programs in that fashion. And then one which is really quite important is all the work at General Motors in, well, they called it DAC, computer. It was their version of CAD. They didn't, like many places, things get a little bit backwards. The right letters. This was a system that IBM had built for them, again in the early 60s. I remember this all starting by Ed Jacks coming to a conference in an Eastern Joint Computer Conference in 62 or 61, and spending the entire time playing with a sketching program that I had written that demonstrated the display on a PDP-1, where people could do that, and I could sort of see this man dreaming this system up. Then he went off and got IBM to build the display, and then this is much later, some ENS flight simulators. I hope we'll see some of that in the films. But these are the early transform, wireframe transform kinds of simulators. Please. This is some output that came out of work at Los Alamos. It's computer output. Now I'd like to turn to just present a few slides. Here's Whirlwind again. The Whirlwind in the about 19. Doug will tell us specifically, but it's in the range of 55 because here's the breadboard for the Cape Cod thing called the Cape Cod system, which was the breadboard of Sage. This is the console room, and then you can see a CRT that had been put to do this work for air traffic control. Whirlwind also had another interactive computer that ran for a few months called MTC, which was used to test the cores, but was never used seriously. In 57, another computer that, let's see. Okay. This is a machine that was designed by Wes Clark, the TX0. And this was, picture was taken in 59, where we were doing speech research. You'll notice that there are 2 Japanese researchers there even then, and they continue to lead. But this is me as a youth, and interactive console, and we strictly used the machine as a scientific, personal scientific computer. And then one might look at this as also the forerunner of the Link. One that, next slide, please. This is some work that was done in that same time frame, 1957, of computer-generated images, and this was the transducer. This is that was done on the SEAC. Standards Eastern Automatic Computer by the Bureau of Standards, when the Bureau of Standards was interested in computing. Now they're interested in stopping computing. Sage, next slide please. This is the mechanism for the output again. Next slide. And a light gun and a professional working at his workstation trying to dispatch aircraft or identifier to dispatch aircraft. Next slide, please. The light, and then the light gun at the console. Next slide. And then PDP-1 front on, I think of probably, well, certainly the first personal computer that had CRT output. It sold, that configuration there sold for about $130,000. 1,000 point by 1,000 point point plotting display, and 30 microseconds a point, and that machine I think probably had 12 kilobytes of memory. Next slide. And that created one of the most famous things in this sort of 62, 63 timeframe, space war, which is the bane, which has now been useful in shooting down lots of claims in computer games, patent claims. If you come to the museum, you can play Space War on the PDB-1, or play it on a Mac that runs the same program. Next slide. The RAN tablet, which I guess that's not in the, or we have that in the museum, and that one may be the museum one. Next slide. And then better one of the globe that John wore, the MIT Globe, 1963. Next slide. And 65, Lockheed had bought a 340 using and a PDP-7, and people were now starting to do serious, or that is, more than one place was trying to do professional or computer-aided design, and a switch input, light pin control, and that. Next slide. And that person created that, which is a rudder control wheel for some kind of a I think the Lockheed something. Next slide. Assumographics and tells you something about how long things take. Here's a copy of the RAN tablet, 1975 by Assumographics. Next slide. If you want to do that in 3D, that took till 1980, 18 years after the RAN tablet. Next slide. If you want to do it intelligently, that thing is a better tracker of input. That sort of took till 82. And then if you want to do it, next slide, if you want to do that transparent, that took until 84. And then next slide, please. And this is kind of how I think of things, as you have a bunch of ideas. Those ideas get translated into projects, and we run a project for a while. There's the perceived need is always, that's log scale. That's at least 2 orders of magnitude away. So the need is always higher than what the technology can do. The ideas are, I guess sometimes I should show the ideas above the perceived need. And mostly a lot of the ideas we'll have here are above the perceived need. And that's sort of the process. And next slide. And this is the final one to say why I'm eminently qualified to give this talk as a workstation. I am the average man. This is the Dreyfus thing, and a few years ago I weighed the exact weight and was at the exact height of the average man. So anyway, that's that. Let me go. Okay. This talk is the paper is a little bit like the Mark Twain comment that I didn't have time to write a short letter, so I wrote a long one. I've been involved in starting up a company, and that's taken a fair amount of time. The point of view that Alan and I, that I've kind of taken in the paper, which is the one that I always kind of take, is that personal workstations are but another member of the computer classes, and for various reasons form. And I have, I'll take a minute and sort of say, I'm a technology bigot, in effect, or probably a hardware technology bigot. People associate me a lot with, mostly with computer hardware. But it's only because I sort of make the point that, in fact, there is this technology hardware devil that drives us all. And from that hardware technology, various components form, and those form the computer classes. So in effect, the technology, this underlying semiconductor density technology and magnetic density technology, I think are the enabling factors from which all of the our machine structures form, and it's like a devil. It keeps going ahead in spite of us. with that, you look at what happens, and no matter how hard we try, very often that technology can't be accelerated just because of a whole set of conspiracies. And then the other thing that happens is we seem to get no product before its technological time, no matter how hard we try, because we are at these time limits. So I have always sort of insisted about forecasting technology, because I, in sort of the early 70s, observed that was the thing, that was the phenomena that was driving everything. And in 75 came up, and I was insistent that in fact it become that this be a very simple function that we predict on. And so in 75 I was able to get it down to only one variable. And so this is the chart that is from the original in 1975. It's in the proceedings, but in fact the one variable is memory price. And in 75 I was able to plot this chart, and for the first thing of plotting exponentials, and all the technology predictors use exponentials in this way and do this kind of stuff. But most of them never insist that the past data adhere to the future. They never bother with the past data. The first thing I like about prediction is I like to be able to predict the past. And so this had a nice property. I said it was done in 75, that in fact it would allow me to predict the past. And I was able to run things back to the PDP-1 and link and the PDP-5 and the 8. And the idea of this rain coming down here, most people only draw one line. I observed that the only thing that really matters is memory price, and then memory size is a single variable. Alan and I played this game in the book Computer Structure. Is if you only had one number to talk about a computer, what would you say about it? And I think it's like any animal. You look at how big is its brain size. And so this is simply brain size of the computer, and from that you determine all of the computer classes. So if you want to explain computers in one graph, this is the basic graph. I have an updated version of it stopped working as well as I wanted it to in 1980, and there's a reason for that. I'll get into that slide a little later. But this, by the way, these lines are 20% cost reduction lines. This I derived from fundamentals at the time at DEC, and that was DEC markups and what did it cost to string cores. And so it went back to Hong Kong for its roots, and it was able, and so we were able to show how one went through dedicated machines up through very general purpose machines. So, and what that phenomena does, what the rain does in effect, is as you go down in price for a given function, what tends to happen is the same computer gets reinvented by a bunch of different people, and then this forms a new market or a new computer class, such as a workstation or a personal computer or a pocket calculator or a pocket computer or what have you. And then these people who built this old computer based on these ideas, you trace a lot of, by that reasoning, you should trace a lot of the ideas back to Seymour Cray, which we can. And the other thing that happens is those people who built that computer then conspire with all their market friends as engineers. They don't want to build that computer because that's a different problem, namely, how do you build a lower price computer? By this time you've got a market established, and You don't want to build that computer because you don't know the customers. You know these customers because they are constant budget customers. So you know, the large computer comp center people always have, originally they used to have $3 or $4 million to spend. Now they got about $15 million to spend on a computer, and they buy one every 5 years. So that's sort of the inflation. You don't know what the computer does, but you know how much you're going to pay for it. And so that's the basic model that I believe allows us to form the computers. Computer classes, and for that I've plotted what I think are a number of the seminal machines here in terms of, these are, by the way, these are the production machines, or they're the machine at first use where a number of people can use them, and for the experimental work you have to go back a number of years, and you can identify various people that were involved in that use. But this starts, and there's a line of computers here that people used as personal computers, starting with the G15 and then the PDP-1. Sort of that line, $100,000 was seems to be always a reasonable amount, independent of the fact that $100,000 then bought quite a lot more than it does now. Was the amount that, kind of a magic number of how much one would spend to let it be used by an individual before you felt compelled to share it and put it in a batch mode and have to have an organization. All these machines up here are essentially say, you've got to have an organization run. Actually, the line is kind of like that because people do account for inflation. That you have to have an organization run it rather than an individual. And then what that does is the idea of forming computer classes. I had worked on 3 classes. Namely, I thought the world evolved around these departmental central machines and workstations. So I sort of have had a 3-level hierarchy for the machines that I've been involved with. And that's work, that observation came out in about 1972 or so. I wrote a paper that sort of started to observe that. That was clarified in '75 when started seeing these the existence of these personal workstations, and then in order to account for the mainframes, added that one. Dave Nelson, who was head of research at Apollo and was formerly in the research group at DEC, took this and formulated it and gave it tier numbers, and then a price function, which he says is 10 times 10 to the tier number in price, and using order of magnitude separations there, about the factors that one thinks of as different kind of computer. And then he also used that and said they weigh about this amount. But those came out of an observation. I have slides that I am not getting into that. In fact, you buy computers by the pound. You say how much it weighs, and you know what its price is, and if you know the technology and the time, and you know roughly what it's going to do or could do. So the computer classes, I think, are an important part of that. If you look at the evolution of let's focus more on personal workstations, that the ideas were really done on small computers in the 50s. That is, we saw the Whirlwind being used that way. In fact, I read a book the other day on graphics that said, hey, EDSAC was the first personal computer. Well, for those of you who don't remember EDSAC, it was probably the first first used machine that was operating in '49 at Cambridge University. It was a one of a kind when universities built and used their own own computer. But it was, the claim there was, since it had since its memory was a CRT, and you could observe what the bits were, it had bitmap graphics like all works. And you could photograph the memory bits, and people did and got functions out of those that, in fact, it was often used as a personal computer. But a lot of the experiments were done there. In the 60s, people used large computers as though they were personal computers, the TX, that work on the TX2. And then a real personal computer came out of that, the Link. And when people ask me what the first personal computer is, I have to say it's Link. Even though there were people using LGP 30s and G15s, if you've ever used paper tape and had to do offline preparation, or have you ever used cards? I hope some of you are old enough to know people who use cards. I used cards one year, was a Fulbright scholar in '59. I went to Carnegie and found key punches, and that's why I wrote a book. I didn't want to compute because, and they also had the 360-67, it just arrived. But the people were using those machines as breadboards, and then in the 70s, a lot of these ideas created a whole set of industries, of people using mini computers and putting one or two graphics terminals, high-performance graphics terminals on those, such as the Adage and the raster graphics, and there are only about 100 companies that do that, many of which formed in the early 60s. And the goal there was to get the cost per workstation seat down in the order of $50,000. And you could do that with a $50,000 terminal and a couple of $25,000 graphics terminals. The other thing that happened during that time was we have the prototypes of the distributed workstations forming here at Park, and then a machine that I think we ought to, in this process, I hope somebody will stand up for and tell us all about it when the time comes, is the data point, which was a bunch of distributed workstations using an 8080 or 8008, the first one did, on a local area network. And I don't know whether that I think preceded most everything else. This may be one of these events that we don't know why it happened. And then finally in '81, with the devil providing all of these resources, namely the right memory sizes and the powerful microprocessor. Two enabling factors here was the micro and the memory size. And you form a bunch of distributed workstation companies, the Apollo, Sun, and the Xerox bringing their product to market. And then by '83, everybody realized there were too many of these companies, and there were only like 100 starting out to build this, given that people could. And so the word JAWS was coined of, do you have just another workstation? So there was a JAWS Co. And then by '85, large companies beginning to embrace that concept, and probably by, I thought IBM would have announced by now, but in '86, sort of embracing it and saying that of course that's the way you do this thing. And then you shake out in a few years or a year or so, a bunch of these companies will begin to shake out. You get a steady state supply, and then we've got this threat. Alan said, we've got to hold this conference because workstations are going to disappear. And I think to a large extent, they're going to, a large number of them, of what we think of as workstations, the evolutionary form of that will, because the, quote, the personal computer, but by then the personal computer, as I've defined it, will be the workstation. The other thing I wanted to do on how the identification of these workstations was to show this graph, which is, again, the memory size line of when you can build a workstation of given capability. And these were my lines that I had in 1975 that I said would predict the past. But I found out they were starting to fail. And I said, why are they failing? And that was because I was so conservative about technology. These lines are all 20% per year decline lines. That's every 10 years you have a decade drop in price. And so if you go back to those computer class models, which you may or may not argue with, but that says what was a computer 10 years ago in one class is now a computer 10 years, can be built an order of magnitude cheaper and forms a new machine class. So these are 10 years per factor of 10 per decade, and this is a factor of 10 in 5 years. Oops. Somebody else may not want that. And this is like 36% per year decline. So this is a twist that I put on about a year ago, trying to account for that. And now you say, why do these knees sort of go out like that? And that's, of course, because the memory density increases. You build a factor of 4 bigger chips every 3 years. So the magic number is also the 36% is factor of 4 every 3 years. So there's this decline line. That's an important part of what determines a workstation. The other phenomena is how much do you pay for a workstation, and that's a function of who uses it. So, for a few people, a Cray is a reasonable personal workstation. If you get that kind of use. In fact, some of them, some Crays are used virtually in a personal workstation form. It's a little bit expensive, but it's sort of off these scales. But in fact, the thing that I've observed over time is never judge exactly how much people are willing to spend as a single user for a computer. It's what benefit you get is the important thing. So here, starting with Link, one would argue, well, maybe that was a little bit expensive at below 50K. But in fact, if you take the sort of constant price line, Link today would be about 3.5. These are the inflationary lines, about 3.5 times the price of that, in the order of 150K today. And we find a personal workstation in that range, the Pixar, for example. This line is kind of the cost of a supported professional per year, and you say, gee, would you provide the same amount of computing for that person as you pay for the individual? And then starting professional, you have a band of starting professional salaries, and then you've got this clerical line here that deals with some of the other things. So what Alan this tries to show what Alan was worried about, that in fact you have a machine here today and suddenly that given machine is going to drop by a factor of 10 in 5 years, and so you're stuck. So workstations, of course, will disappear, and IBM will eat them all up right here with the next version of the PC. Or the Mac could eat them up. But you have this major cliff that you're falling off, and these machines are done. So the trick is to increase the power here at those price levels and make it possible for the individual to get more done. And then you run into the problem, since this is a coupled system of a human and a computer, that if you can't get that software there, you may just be plain old person limited rather than computer limited. So we hit the CPU in workstation, and it may be the CPU and the memory of the individual using it as the limit, not the workstation. So the trick is to, for us who build these, is to provide more and more. This is again, the technology devil. This is in the packet, but every 3 years we see these memory chips, and this is really the big devil driver here. And then following that, I'd say things could have happened a lot faster if the people building semiconductors had known how to build processors. But that was a new group of people were building them. They were semiconductor people and circuit people, not computer people. Now I call these people semi-computer people. There is almost a good processor, so a lot of good workstations can be formed with that. And it took about, interesting thing, to get a good processor only took about 13 or 14 years, and that's about how long it's taken everybody from the beginning of when you could identify when they built their first computer till the time when they could build one that you could actually use really well. That happened with minis, it happened in mainframes, and it's happened in the micros. So that led me to a definition of, well, what's a personal workstation? Because I think the definition will change at any point in time. And there's two words here with it. First off, that's a professional personal computer. And so I looked at a bunch of definitions and said, what's a profession? And then this one, we'll get a lot of argument. I mean, this conference kind of needs to deal with this, and I felt obligated to deal with it in the talk. And I said, I took a really broad definition here. Any vocation, occupation, or business associated with work. So playing doesn't count here. Maybe searching for the workstation doesn't count either, so this would rule out the park work, for example. But let me not do that. That I want historians to search out. I just want to raise these questions. And that would, but with that you would put in secretarial, and not spelling, commercial, science, engineering, mathematics, and the arts. People who are doing work and are creating, as getting paid to do. Basically, it's anybody who gets paid to do something. So those guys identifying aircraft that was a distributed, shared workstation. And then what's a personal computer? And I thought that we ought to identify what that is clearly, and that's a self-contained computer with secondary, its own file memory and appropriate transducers. Whoops, this is really bad. Used with one person at a time, used by one person at a time at a convenient location. Yeah.
About 5 more minutes?
Yeah. Okay. It's self-contained, and then what people say is the personal computer. That's big PC, not little PC, is an IBM PC. So this was the definition. It's today we think of it as that it's a personal computer, but it's in a distributed, interconnected environment because work has the nature of being interconnected versus being in a private environment. It's large, about 50 pounds, and it's more expensive than a PC, and the price, as I've already talked about. It has a bunch of generic applications, things I call generic, and then the other thing is that it understands the profession. It has all of the tools that professional uses and needs. So those are some starting points for definitions. One of the things I think I would like to see that I would copy from the Hopple book and the books that at least I've been involved with. I can't stand a book without one diagram that has the whole book on it, and book in it. From a timing standpoint, I would like to see us do all of the dimensions of the personal workstation. So we've got the hardware dimensions, which are really the processor memory evolution dimensions. We've got the graphics output dimensions, all of the work, and I would believe that our friends in conferences, that ought to be a conference and thing that's done by SIGGRAPH, because those people understand, they have been the evolution, the drive behind that. Dealing with that, the whole idea of plotting and printing is a very important part of graphics output. Tactile input, some of the transducers I showed you are important. Voice is beginning to be important and useful in that. Lands, and these are all dimensions that, and it's important to have them all in one timeline so you can see how these hardware influence some particular physical workstations. And then on top of that, we then start building our operating systems and programming environments. Then these generic environments for filing and editing and communicating. And then finally, on top of that, we build the profession-specific environments. To show what I mean, I stole as much as I could from somebody else. This is in the IEEE Computer Magazine, showing the evolution of the environments, the user environments, and this illustrates my point of how long does it take for ideas to go from mainframes to minis to processors, and we find that this idea A occurred like that, this idea C occurred there, and we can show when these sort of important ideas, or when these various computers reached a level that were important for workstation use. So what I mean by a timeline is that we would take each of these dimensions and go off and put those together. What were the really important ideas in graphics, in operating systems and languages? So that, in fact, workstations, in a sense, is a combination of all those. And then the other thing, finally, the other thing is the professions are segment, and they all demand their particular kind. I guess the reason for this, I have the two last slides, and that is, the reason I sort of take this view was that I look at a system, the systems we built, let's say 65 to 85, single user shared systems. The first one I worked on was in 65. Of looking at the functions that were being performed, I saw the PC coming in the 78, 85 time frame. The first thing that got us hooked was a link to the shared system because you needed a file system. And then certainly the distributed model is basically that. You take all of these functions, the file system, the printer, and the first thing you do is by building a PC is find out that you've got to hook in and you're now a computer center director, and then as you further pull all those functions apart, you find out then you've got to connect them together. I don't see this environment, no big deal of whether you have them separated or whether they're in a single function. The important thing is what they do. And for some of the graphics, there's no way you can do some of those functions unless you put them in a single place. That's it.
The reason I was chosen to introduce Gordon and to discuss and to sort of lead the discussion is that only a co-author can stop a keynote speaker. Okay, it's a very special privilege. We do have, in fact, I think just a couple of minutes, since we started 15 minutes late. We can take sort of 5 minutes or so for questions. Let me just make one remark before opening it up. Gordon, right at the beginning, said there was sort of a danger of participant history, which we all have to be aware of. There are, in fact, the bias that comes from being participants, although, as Alan Perlis remarked, it's important to get this all out on the table early enough so it gets there before this whole movement disappears a few years from now. There are a couple of other kind of worries in history that one might note. One of them is called Whig history. I don't know how many of you are familiar with that term, which is the fact that one tends to write history by going back into the past and recreating it only as it relates to the future. This turns out not to be a very big danger for us, since since our problem is we are participants. There is yet a third difficulty in history that scientists in general suffer from, which is the writing of internal history. That is, we believe in some sense that everything flows out of our own internal work and science proceeds or technology only on the previous stuff. One of the nice things about Gordon's talk, it seemed to me, is that we all recognize, and he helped us to do that we are driven fairly strongly by the commercial and the driver that's outside of us, which is this technology driver, and consequently we are not likely to forget, and Gordon certainly didn't, we are not likely to forget how much of our history is not internally generated but is generated by the outside boundary conditions, although as Gordon and I were saying a moment ago, the work still has to be done to get from those technologies to the actual workstations. There is yet one more difficulty in history that I think is peculiarly indicated, if I may criticize Gordon's talk a little bit, and that's another privilege of a co-author. You're not supposed to criticize Keynote. You can criticize all the other talks, but not Keynote talks, but I can criticize the Keynote talk. The other danger that's peculiar to the workstation and graphics part of the world is when we'll substitute pictures for history, okay? Those pictures are in some sense only the very top points, and the question of the human effort and where the ideas came and the other things that allowed those to happen, the real web of causality sort of lies below those pictures, and one wants to be a little careful, and he did. He finally switched and gave the other half of his talk on that. I'm glad he did, actually, to sort of pose this framework. Let me open it up now for comments and contributions and corrections and so forth, because in fact you're allowed to criticize his talk too. And will you do so by coming to the microphones and giving your name first, so that they have that on the record? Fine. You don't have to hold up your hand. Just go stand in line. Yes, Doug.
Doug Ross, you'll hear me next. But Gordon invited comments on his early slides there, and I have just two. I'm really glad that you had that picture of the whirlwind test control area, because I have a later one. Yours, I believe, is from 51 or 52, very early. You can figure that out from the MITRE company's sets. But that is earlier than the actual inclusion of the SAGE stuff, Cape Cod material. The other comment is, with respect to the start of Ed Jack's interest in computer-aided design at General Motors. I'm not sure, because I haven't checked my records, whether it was before or after his being enamored with what he could actually do with the PDP-1. But at one point, he and Don Hart visited me at MIT, and we had done some of the light cannon work going that I'll talk about, and on the 704. And he had at his plant none of the real-time package that IBM supplied, but he had a very clever technician who knew all about how the online printer worked. And so in order to make his first tracking program there at the beginning of DAC, project, they used the EchoCheck circuitry that was built into the online connected line printer. That was the only way they could figure out, this technician could figure out to get a signal back into the computer. They hooked that up to a photomultiplier tube, and sure enough, we're tracking shadow similar, or either light or shadow, I'm not sure, similar to what I'll be talking about. So I thought that was an interesting comment on your DAC thing.
Year was that?
Must have been either 60 or 61. I'm not really sure whether it came before, after.
That visit, yeah.
It's in that same period.
Right.
Oh, John Brackett.
Is that
Is mic on? Okay.
Okay.
John Brackett. I would hope that when the history actually gets written, some of the key software events, rather than just hardware events that made personal workstations possible, will be perhaps more identified. Let me just point out a couple I think that other speakers may come back to. Clearly, when computers in an interactive mode started to be used by professionals that were not familiar with programming, is somewhat of a milestone. Personally, Glenn Culver was the person that got me into this field, although he probably doesn't know it, when I first saw as a chemist his system in 1961 or early 62. But I also believe, I hope Dr. Licklider comes back to the fact that at least I believe, in the period of 64, 65, on the MIT time-sharing system. They became a critical mass of software that began to bring people from the sciences and engineering who had never written a program to use what I will call program-oriented languages, systems that required no real knowledge of how the system worked. And really, if we talk about professional workstations, clearly many of the people from the professions had not the slightest idea how to write a Fortran program or a Lisp program, but came to these systems. There's also an event which perhaps Dr. Licklider will come back to, was when a person who knew nothing about the internal storage of information in the MIT time-sharing system was able to share other people's information. I remember when that came on the system. And in fact, the idea you could use other people's programs without knowing anything about where they were to build even larger pieces of software. And I believe that was in early '65. Was also a very interesting step forward, I believe, in software. So hopefully the software side of key events in this industry will get into the history also.
Severo, did I see your? Oh, you were just waving at somebody. Oh. Okay, are there other questions? Oh, fine, yeah.
Thelma Estrin, UCLA. I think another part of the history is the pull of the application or the pull of the professionals and how strong the need is and when the technology is ready to answer that. And I was at the Brain Research Institute all through the 60s, and we also had a color-freed personal workstation, really, and we used it for graphics and a whole bunch of things. And that is not in any history because it's tied up with grants to NIH to try to get funding for brain research. And I think there are probably other examples when the history comes to about what the contributions were from different application space, which very often is just internal because it never made it to the marketplace or never got expanded except in small papers at specialized conferences.
Alan Kay, Apple. Just have two little footnotes. One is the 3D stuff that was sort of intermixed in with Sketchpad was by Tim Johnson, and it was actually reasonably after, I think it was 63, 64 when that stuff was done. It was sort of overlapped with Ivan's work. And the other one was that the RAN flowcharting stuff, the character recognizer was done by Gabe Groner. And all of that stuff was done before Balzer went there. And the movie that you showed was the RAN video graphics system, which was after the original Grail system, which was done on a Burroughs display connected to 360 Model 50, as I recall. So that stuff was done a little bit earlier. I have the early movie of that I'm going to show a little bit of tonight.
Fine, thank you.